Question 7 is coordinate geometry. So in part A, we need to write in the points A and B. So we can see A here is 1, 1, and B is over 6 down minus 1. Now we need to put the two coordinates C and D onto the graph. So we have 8, 4, so out 8 and up 4 for C, just label it, and out 3 and up 6 for D. Now in part B, Paulina wants to prove ABCD is actually a square, and in part 1 of this question, we need to show that the length of AB is equal to the length of BC. So I have the distance formula here, so we're going to utilize this with the points AB and CD. So let's assign x1, y1 to the coordinates to link up with the formula. So just put x1, y1 here and x2, y2 here. So let's get the length of AB with the formula. So you can see substitute your values inside brackets. So we have x2 minus x1, which is 6 minus 1, all to be squared, plus y2 minus y1, which is minus 1 minus 1, close your bracket, all to be squared. We can see that that's 5 squared plus 2 minus 2 squared, which is the square root of 27. Just use your calculator. Now on to BD, and we're going to BC, so we're going to use the same system. So we can see here we have x1, y1 and x2, y2 over here. Okay, so let's go again, and we can say that x2 minus x1, which is 8 minus 6, ought to be squared, plus 4 y2 minus y1. So it'll be minus minus 1. So be very careful with the signs. Close your brackets. And again, that's 2 squared plus 5 squared, which is a square root of 27. So therefore, the length of BC is equal to AB. Now in part 2, without measuring the diagram, which refers to using a protractor, setting it here. So we're not going to do this manually. We're going to use this, do some algebra here with the slope formula. So get the slope formula from your log tables and assign your coordinates again. So we have AB, again that's x1, y1, x2, y2, and let's put them together in the formula. So we have y2 minus y1, which is minus 1 minus 1 over x2 minus x1. So we can see here x2 is 6 minus 1. So it's 6 minus 1. So it's equal to a slope of minus 2 over plus 5. Now let's see, is the slope of BC the inverse or the perpendicular to the slope of AB? So again, assign x1, y1, and let's use the same formula. So m is equal to, so y2 minus y1 is just 4 minus minus 1, and x2 minus x1 over here, this is x2 minus x1, which is 8 minus 6, and we have a value of plus 5 over plus 2. Okay, so this is the perpendicular to this. Okay, so if we want to prove it as well and go a step further, if you multiply the slopes together, m1 by m2, let's go m1 and m2, we should get minus 1 if they're inverse. So if we multiply them together, yes, we will get a minus 1. So part C is the final part, and here we have a statement. Kieran's statement is every parallelogram is a square. So is Kieran's statement true or false? So we know that it's false as we could have a rectangle. Okay, so a rectangle is a parallelogram. Okay, and it's not a square. Something straightforward like that, but explain it and write it out. Write down the converse of Kieran's statement. So the converse will be the opposite logical statement. So over here, we can see that every parallelogram is a square, but we can say that every square is a parallelogram. And that's true.